Good evening, wherever you are. My name is Arun Gupta. I'm the Vice President and General Manager for Open Ecosystem Team at Intel. We're very happy that you're here. You can find us all about at open.intel.com. Follow us on Twitter/X at open at Intel, or follow a beautiful podcast series that we have again at open.intel.com. And today I'm really excited to have Marcus with me. Hello, Marcus.
Hey Arun, good to be here.
Thank you. Thank you for being here. This is one of the very unique sessions. Up until now, we call this as hallway conversations. I meet all these wonderful people around the world and have these fun hacking sessions, fun discussions with them.
Yeah,
And this whole initiative is about why have them in private? This is open source. Let's have them in public. And so this is really a hallway conversation series, really here. And today I'm particularly excited because we are going to do some live coding, live hacking here. So,
excellent.
Marcus, tell us about what do you do, first of all?
I am the VP of DevRel at a company called Vaadin. So we're a company who help folks on Java backends build really great web UIs. For that, we have a big library of UI components that you kind of all the building blocks you need when you're building good-looking applications. And then we have two different frameworks that you can use to build them, either fully in Java or our latest framework, Hilla, that I think we're going to take a look at today, which allows us to kind of seamlessly put together a Spring Boot backend with a React front end.
Oh, wonderful. Okay, cool. So, and what are we live hacking today?
So today, I mean, you might have heard of ChatGPT. You might have
Yeah,
even tried it.
yeah.
Um, and a while back, I was like, well, I mean, a lot of the AI tooling out there is really targeting like Python or JavaScript developers. And I was like, well, I really enjoy using Java and Spring Boot on the back end. Like, what tools do we have available for us? And that led me down a path of exploring different options, building different kind of chatbots and AI powered tools on my own in Java, and that I think was really interesting and just great to see how much the tooling has evolved since I built my first AI chatbot. I think say April maybe of this year, and I had to like literally do everything. I was counting tokens by hand to make sure I wouldn't like send too much stuff over to the LLM. And today there are tools that like whittle down that 2,000 lines of code to like literally 4 lines of code, and it's like so great as a developer. Now I can focus again on just like getting my stuff done instead of having to deal with all the plumbing. So I'm going from like assembly code to high level programming language in essentially half a year. So it's been just remarkable.
It's like a cycle, right? You always start with a low level programming, and
Yeah,
then the abstraction keeps going up the layer. And this is
yeah,
okay, I'm no longer programming x86. I'm actually programming on a 3GL, 4GL language, and that brings a lot of fun. And the funny part is you said April. It feels like such a long time ago, particularly how fast things have been moving in the AI space, and that libraries are evolving and the abstractions are coming up. So you mentioned you're going to use Java, you're going to
yeah.
use Spring Boot. That's sort of the classical way how Java developers build their Java applications.
hmm
What are the other components we're going to use for this?
So we're going to use an AI library called LangChain, which is probably the biggest kind of tool out there when it comes to orchestrating different parts of working with an LLM. So again, like I mentioned earlier, I using this library, I can just tell it like keep track of, I don't know, say the last 10 messages of this history or chat history, or maybe a certain amount of tokens worth of it. Instead of me having to do that, it takes care of it. But what's even more interesting, and I don't know if we'll have time to go into this, but you can also kind of start plugging in different uh, things into it. So you could essentially give it access to some tools in your application, so it could actually call your backend to fetch some stuff from your database, or you could do what we call retrieval augmented generation, where you essentially you give access to the for the LLM to kind of fetch relevant piece of information from a vector database. So that way you can give it access to just a much bigger library of content than it could normally have access to. And in our case, like one of the first chatbots I built was a documentation assistant for our tooling. And What's challenging is that we have different versions of this, and essentially you can do the same thing either fully in Java or in React. And what this allowed me to do is I can, by switching kind of which namespace in the database I'm fetching those kind of reference materials from, you can ask the same thing as like, how do I build a form? And it will give you the exact right answer using the exact stack that you're interested in. And it just kind of opens up a whole bunch of interesting opportunities. But today, I think we're going to stick to more the basics and just kind of look at how
Yeah.
the basic flow works. And just knowing that once you have this set up, it's very easy to kind of plug in any of the other functionalities that LangChain offers as well.
And by the way, I would love to kind of bring you in. Like, let's look at the basic functionality, and maybe we can do a future webinar on those advanced capabilities.
Mm-hmm.
Now, LangChain is a Java library. Is that what you said?
So the original LangChain is a Python library, and very quickly after that, they created a JavaScript version of that. Later, I think like early summer, a new project popped up called LangChain4j, which is a Java port of LangChain, and it's been very active. You can see there are contributors from all kinds of different big companies and small companies and individuals working on this. So it's just developing at a breakneck speed. A lot of new functionalities, new supported LLMs and databases and
Beautiful.
tools and stuff coming almost every week.
Got it. And I was watching a talk from DevOps Belgium, which happened in October. Lies Reis, apparently one of the maintainers of LangChain4j, gave a beautiful talk on how to create that. Now, and I'm getting impatient to get into the code, but just to get the basics right, Java, Spring Boot, LangChain4j. What was that Hilla part that you talked about? What is Hilla?
So Hilla is our new framework for building full stack web apps on a Java backend specifically. So what it allows you to do is build a front end in React using our library of UI components or any other React components for that matter. What makes it special is that because it's a full stack framework, we can do a lot of things that a more decoupled framework doesn't allow you to do. So you'll notice when we start building this, the way we're actually interacting with the backend is very different from what you would be used to, like doing a REST call or a GraphQL call. Essentially, we can take a Spring service or a Spring Bean, annotate it with a browser callable annotation. And what that does is it generates the needed TypeScript code and types for us to just call the same method signature
Gotcha.
in TypeScript with the same type information and everything. So it's essentially like we're building one app, even though we're kind of running it in two
It's very
separate places.
declarative, is what you're telling me. At the very high level. Okay, you know what?
Yeah, I think code will explain this better than I can ever do in words.
So we learned all the components over here. Usually, I would say it's a live coding session. Let's pop out the popcorn. But this is California morning, so I'm gonna pop out my blueberries. I'm gonna munch on blueberries, and I would love to see you hack coding here. So let me actually bring your screen up here, because that's
Yep.
what we're going to be using primarily. And let me fix the setup here. All right, walk us through. So what are we building today?
All right, so we are going to take a look at building a ChatGPT clone. So what we're essentially interested in doing is calling OpenAI with a message of our own, send it there, get a response back. And we're going to take a look at how we can do that using the LangChain4j library that I mentioned. So you can find this on GitHub. We're going to use Hilla, which we just talked about, which combines the Spring Boot backend and the React front end. And I think that's all the theory we need. From there, we're just going to hop into code. So here I have a project already opened, and let's just really quickly orientate ourselves in this project. So we can see that we are in a Spring Boot project. We have the classic source main Java here with a Spring Boot application. And
what you're using here is a Visual Studio Code?
This is actually IntelliJ IDE with the new UI update that they came out with a couple of months ago.
Because I'm seeing a .vs code file over there, and that's what confused me a little bit.
Okay, yeah, no, that's yeah, I've opened this in VS Code as well, so it's a little confusing. Maybe we can let's remove that. not relevant to what we're doing here.
Yeah. And this is a very standard Java setup, nothing custom, very typical stack, IntelliJ, Java, Spring Boot, using
Correct.
Maven, generated a Spring Boot application, and that's how you're starting out.
Yeah, and what the only kind of non-standard or different thing here is that we have this front end folder which contains our React application, and the only part we're really interested in here is I've created two views. So we're going to take a look at a simple way of calling ChatGPT, just like ask for a response and we get the full response as one string. That's a really easy way to interact that works for small kind of inputs. And then we're going to take a look at more advanced case where we actually want to stream the response as it's getting generated by the LLM, which is what you're used to seeing in ChatGPT. And like if you're generating a very long response, that's much more user friendly because
Right.
otherwise the UI gets stuck for a long time.
So in
All right.
that standard Spring Boot application, how did you create that front end folder?
So I created this application actually using our Hilla CLI. Looks something like this. So make that bigger. So npx Hilla CLI init project name that gives you a Spring Boot project that's initialized with this. You can also start from Spring Initializer. If you go start Spring IO, you add Hilla as a dependency there. And then there's a Maven or Gradle uh, uh, build target that you can run, which will then generate that folder for you. So you could start from either way. This is what I'm used to doing. So this is what I did here, but
That,
whatever works for you.
yeah, I think the key part is you can start from a Spring Boot and inject this
Yeah,
front end folder, or start with CLI, Hella CLI, which will
yeah,
give you the whole thing anyway packaged up together. Okay, perfect.
correct. Anyway, so we're essentially in a standard, like we have a standard Spring Boot project, we have a standard React project, and really the magic here is just how we communicate with them, and we're going to get to that pretty soon. So before we get there, just want to really quick show that I did add two dependencies here from LangChain4j. So the core dependency and then the LangChain OpenAI. So there are different different APIs we could be calling, and in this particular instance, we're interested in using OpenAI.
So
So
pause there for a second. LangChain is a wrapper API. Go back to the POM XML for a second.
yes,
So LangChain is a wrapper API, and then as a wrapper, it gives you the ability to call a pluggable LLM essentially. And in
hmm
our case, we're going to be using, because ChatGPT is built upon OpenAI, we're going to be using OpenAI as a pluggable LLM there.
that is correct.
Okay, got it. Thank you.
And the nice thing here is that you can start with one, and you can switch to another if you wanted to later. Similar to like some of the tooling we were talking about, like vector databases or embedding, uh, uh, or kind of ways of creating embeddings. And these are things where, like, if I'm developing locally or I'm doing a demo, I'll just do an in-memory thing that works in Java that has zero external dependencies, because that's really how easy for me to just share with you, and you can run it directly without having to set up 3 different services. But then as the project matures, you probably want to switch over to a more robust actual database at some point. But the pluggable architecture makes that pretty straightforward and easy.
That's wonderful, actually. Okay, let's keep going.
All right, good. So let's start on the back end here. So I'm going to go and create a new class here that we're going to call chat service. And this is right now just a Java class, and we're going to add this browser callable annotation that I said. So this, what it does is it turns it into both a Spring Bean. So we could, if we wanted to like we could say that this is a browser callable service if we wanted to be like more explicit, but this is all that we actually need. So we're going to say browser callable. That means that any public method here will be callable from the browser. We are going to say anonymous allowed because we're not going to start setting up Spring security here, but it's good to know that by default, nothing is callable, and you can then define, do you want anyone who's logged in to be able to call anyone with a specific role, and that is actually on a method by method basis. So you have kind of full control over what's callable and what's not. Right. So what I want to do now is, since we're going to call OpenAI, I'm going to need the OpenAI API key. So I'll create a private string
So this OpenAI API key is what you would generate going to the OpenAI portal
Yeah.
and just search for creating OpenAI key, and that creates it for you basically.
Right. And a couple of things to note here. So one is I'm using GitHub Copilot here. So if you're wondering what the gray text is that it's kind of showing here every once in a while, that's
Uh,
completions coming from there.
okay.
I figured it's appropriate if we're going to build an AI thing, we're going to use AI
So
also
it's
in the.
okay, let's digest it for a second. You are using Copilot, which is likely using OpenAI for all that code generation.
Yeah,
You're using a OpenAI powered Copilot to write a code, then to talk to OpenAI to create a ChatGPT clone. So it's like
exactly.
sort of an inception kind of a mode over there.
Exactly. So a little funny. So anyway, on my computer, I write a lot of different small demo apps. So I've defined an environment variable that is open AI API key like this. So that's in my computer environment. It's outside of the app, so I don't need to have it in my code. By injecting it like this in Spring Boot, we get access to it from our Java code here.
Now, how would that
And
work if this were to be deployed in a AWS environment or some other hyperscaler? How would that work?
so in that case, you would define the secret in your AWS environment. So you would set the same key there, and that would allow you to
I
then
see.
access it from
So
there.
it will
So
automatically inject the key value here in this environment variable, and wherever excuse me, wherever you call API key, that key value is available to you.
yeah, that's correct.
Got it.
All right. So what I like to do when I'm working with LangChain4j, because it's evolving quickly, I like to go to their GitHub here, and they have a really good list of different like code examples that we can use to start off with. And what I thought that we're going to do is we're going to start with this very simple one where we just set up a basic chat bot and do a synchronous call. So we just do one call and we get one response. And this allows us to kind of see uh, how the library works. So it has two parts to it. We define an interface uh, that we want to interface the LLM with. So this is similar to like say Spring Data. You define a JPA repository interface, and Spring Data provides you with that implementation. Similarly, here we define an interface, and LangChain4j is going to provide us with an implementation for that. So this is essentially we're saying that our chat should take in a message and it should return a string.
It's your pluggable data source essentially, and in this case, it's going to be powered by OpenAI for us.
Yeah, and then let me see what's happening here. Okay, so I'm going to hide the sidebar here since we're working with very large font size, so that way we can hopefully see.
Yeah.
They were storing their API keys differently. We're going to just use the API key that we have here.
So let's
But
walk us
essentially,
through this code.
what's happening here is we're defining a chat memory. So an LLM by itself doesn't retain a memory. So a context is essentially the working memory, the kind of RAM of our our LLM, and we need to be mindful of how we're using that. So typically, a LLM will have a context window size of say 4,000 to now. Well, ChatGPT 4 Turbo is already like 128 k token window. A token is a way that the LLMs use to kind of break down text into smaller bits that it can do. So essentially, a 4,000 token window translates roughly to 3,000 words of English language, give or take. Anyway, the interesting part here for us is regardless of how big it is, we're going to get charged on the API usage based on how much context window we're sending. So typically, we don't want to be sending, like if we were doing some sort of like documentation bot, we wouldn't want to send it like our entire documentation on everything, because that would be very kind of cost inefficient for us to do that. So in this case, what we want to do is we want to track the message history so that remembers our previous answers, but we want to only do that up to a certain limit. So in this kind of simple example, we're just going to say that just keep the last 10 messages. That's going to be fine. We could swap this out for say a token message window or token size window where it would just say like keep track of 200 or 500 tokens worth of history.
And so this chat memory class is essentially where those 10 messages are going to be stored. So if you want to access any of the context of the history, that's where you can tap into.
Yeah, and it's sending that entire history on every new message that we send. It will append this new message that we have as a continuation of that chat that we're having. Now,
So
this is a very simplified.
when the 11th message is posted, the first message is dropped, and 2 to 11 is what goes back essentially.
That is correct, and especially before ChatGPT 4 Turbo, you could very easily notice this in ChatGPT when you had a long conversation with it. You would start noticing that it completely forgot what you were talking about a couple of minutes ago,
Yeah.
because essentially that sliding window of messages that it kept track of would start dropping messages from the top, and that's why you kind of have to just keep repeating yourself a little bit. Now with the newer models, it's less of an issue, but again, we want to be mindful of like, how much is it really worth for us to send? Okay, so, and maybe one more thing to note here. So this is the simplest possible way. This is now essentially every user of this application is using the same chat message history, which is obviously not what we would want to do. There is a message or there's a provider version of this, which takes in a unique key and returns a specific message history for that key that you can use to kind of give every user in every chat a unique chat history. And that would, of course, be what you'd want to use, but we're going to keep things simple here.
So if we think about it a little bit more, this is all happening in memory.
Yeah.
Now, how do we scale this if we were to start persisting these elements? How would that look like? Like, is there like, do we back end with a persistent data store, or is there a persistent version of this chat memory class?
There are persistent versions of this provider.
Okay.
So you could put that into a more persisted kind of distributed place where you could store that.
Okay.
But again, we're keeping things simple here. So what we're doing then, in order to get an implementation of this interface, is we're using AI services from LangChain and its builder, saying that we want to have an instance of this where we're using OpenAI chat model, meaning that we're going to call an OpenAI LLM and we're passing the API key. We say that this is the memory provider for it, and then we just call build to get the instance. I'm going to pull this up into a field here so that we can or kind of use it from our other methods here. And
so line 30 is where we are plugging in OpenAI, and if we were to swap it with a different LLM, that's where we will swap it essentially.
Yeah, correct.
And that's sort of the wrapper model that LangChain provides, that you could use whatever the backend LLM is. Your front end code, so to say, stays the same, and your backend LLM model can change, and then your accuracy, whatever, can evolve accordingly.
Yeah, that's right. And essentially every line here is swappable. So we were talking about like in memory versus some sort of distributed thing. So again, if we wanted to use OpenAI, but we wanted to not store everything in our like local instance memory, but we wanted to share it store it somewhere else, we would have a different memory provider here, and that would take care of that. But again, the overall structure of this would not change. So
Wonderful.
It's very pluggable. Okay, so then what I did is I created a simple method here with the API that I want to call from the browser. So it's going to be the same API that we had here. It's going to be call chat. It's going to take in a message. It's going to pass that to the assistant. The assistant is again hooked up to the model with the memory, and it will return an answer. So now we have kind of the backend plumbing for the first part of what we need to do here. What I'm going to do is I'm going to build a project. If you're using VS Code or Eclipse, it basically automatically builds, and you don't need to do that manually. On IntelliJ, for reasons unknown to me, you have to manually call build whenever you want that to happen.
Well, so that's really a call to Hadi Hariri, who leads the DevRel for IntelliJ, that, hey, Hadi, this is a call. How can we fix this so that it automatically builds, particularly when VS Code and Eclipse are doing it? And with IntelliJ being at the top end, we would expect it to. I wonder if it's just an option or something, but Yep,
Yeah,
that needs to
there's an
be.
option you can do automatic compilation, but it only works when you're not running the application, which is again I don't know how that works,
Yeah,
but
yeah, that's definitely a request for improvement.
yeah.
Okay.
Anyway, so what happens now, because we are using Hilla, we have this browser callable here. It will generate into this generated source code folder, kind of a TypeScript implementation of, or kind of TypeScript wrapper for calling this method with all the same type information. So we can actually go into our React view here and start using that. So Arun, how familiar are you with React programming as a
I've
as a
barely
concept?
dabbled in it, but I'm sure our audience is way more technical into it.
Yeah. Anyway, so React component is essentially a JavaScript function, or a TypeScript in our case, because we're using TypeScript, that returns a snippet of HTML, which is the template, and that template can depend on a state. And whenever the state changes, React will automatically re-render this. So essentially, the template should always be a function of the state, and that way, whatever we see in the browser is a function of that state. So there are a couple of things that we want to do here. We want to have our state in this case would be the array of messages that we have, the messages going back and forth with the LLM, and the template here should have components where we can display those messages and where we can input messages. So for that, I'm going to use
So
the
whenever the
built-in.
state changes at the back end is when this model gets updated and the new template is generated and refreshed in the browser, essentially. Is that right?
No, so these state changes are all happening in the browser, but we'll get to that in just a
Okay.
moment here. So what I'm going to do is I'm going to pull a couple of the components that we have in the library here. Like you can see, Copilot is trying to give me a whole lot of Tailwind code here to do it, but we have a very much simpler way of doing that. So we're going to use a message list component, and then we're going to use a message input component. Since these are very common patterns found in business applications around the world, it doesn't make sense for every person to have like those 200 lines of Tailwind in their app. So we can see that with those two lines, we already have I'm going to minify this a little bit so we can
Yeah,
see
as
everything at
soon as I
one.
type message input, the window updated here is saying, okay, what is the message input? And the send button automatically came in.
Yeah, so the message input here is what we see there.
Right.
You can see also that as we're changing the TypeScript code here and saving, that's getting automatically uploaded or updated here in the browser more or less
Yeah.
instantaneously. So it's really quick for us to see. Now, the message list itself here is kind of compacted to nothing because there are no messages right now. And what I want to do is I want to have the input here on the bottom as
Right.
every chat UI in the world. We're using
Yeah.
we're using kind of utility classes like Tailwind style. And because I'm in a Flexbox, what I can do is I can give it a CSS class name of Flex Grow, which will tell the CSS Flexbox to
I see.
grow this area with any available space. And that essentially gets us to where we need to go.
Mhm.
Okay, so what we need to do then, I said we need a state to keep track of the messages, and we need a way to actually send that message to the backend and get it back. So we'll start with the state. I'll write this out and then I'll explain what's happening because it's a little kind of weird potentially. So we're gonna message list item. Right, so what this does, this is a React specific thing for managing state. So useState will return an array of 2 items that we, using array destructuring, pull into 2 just named constants. So we have one constant called messages, which is the current list of messages, and then we have a setter function for the state. So when we call the setter function, React knows that that state has changed, which it can then use to re-render this template. We're using TypeScript, so I type this with the type of messages that we have, and that's the expected input here, the message list. So right now we're starting with an empty array, so we don't have anything, but we could just verify that this works. So we can see that it takes in the text. We can say hello, and then it takes in a username, John Doe. If we save that and we add these messages as the input items, we can see that those show up here. So we're this this array of messages is now what's backing this message list.
So help me understand, how did the chat view item, no, sorry, chat view is a bigger function, but talk to me about this connection between message. Oh, I see. In the items, we have messages listed over there, and messages is what is getting initialized in the constant, and that's what is getting populated.
Yeah. So this reads a little weird, especially if you're not used to
Yeah,
TypeScript. So we're calling use state with an initial value. The initial value is an empty array, and this here is a type similar to Java. You have
got it.
brackets for state, saying that the type of this state is a array of message list items.
Right.
So that's how to read this. Okay, so let's then hook up the actual message input here. So we want to click on the send button here, and we want to have that call the backend and update here. So what we're going to do is we're going to create an async function. That seems good. So we're going to call it send message. It's going to take in a message, and then it's going to do things. Now, again, you can see Copilot is giving us an idea of what it might look like if we weren't using Hilla. So now it disappeared. We would probably post to a REST API, and we would get the response back and do something with it. It's going to look a little bit easier with Hilla. So we're going to do this. So we're going to, first of all, we're going to add whatever message we just sent. We're going to add to this messages list.
Right.
So we're going to call set messages, and and again, I'll explain what's happening here in a sec. So we're going to say that the text will be the message, and the user name will be me. So what's happening here is we're assigning a new array. So we're using the brackets to create a new array. This syntax here means that we're going to explode all the previous items from the previous messages arrays there, and then the last item in that array is this new item. The reason we're going through all of this instead of just calling push with a new item is that React tracks only the reference to the array, not the contents of the array. So we're essentially working with immutable data structures here, which is why we're creating a new array, if that makes sense.
Right.
So then we want to get the response, and that would look something like this if we were using REST, but we're going to call our chat service, and we can actually see that we were able to import in TypeScript the same chat service that we had, and we can use auto
connection that is providing, because
yeah, and we
we
can exactly, and we can now see that we have this chat function here that we can call. It takes in a message like that.
Beautiful.
So it's all typed. It's helping me explore the APIs directly through my IDE here. So once we have the response, we want to do this. So we, again, do the exact same thing, except we now pass in the response as the text and saying that the bot was who wrote this. So if things went well and the demo gods are on our side, we should be able to say something fun here.
Let's find out.
Tell me a joke. Let's see if that works. No, I forgot the most crucial thing. You actually have to say that should happen when we should call the method when it actually gets when we submit the input. So let's do that. So we're going to call.
Well, I mean, that only proves this is the real deal. We are actually coding it live. So yeah.
All right. So we're just going to pull out the value from the event, and then we're going to say, hey, tell me a joke.
Why don't scientists trust atoms? Because they make up everything. Yeah.
Very classic. And we also we ran into a very classic React problem here, but go ahead. You tell yours first, and I'll fix the code after that.
Yeah. No, but I think this is the moment to take a pause on, because if I were to put it all together, we are using Java, Spring Boot together. We built this application using IntelliJ. We are using LangChain as the backend library. We're using Hilla as the front end. LangChain is using OpenAI as the further LLM backend, which is pluggable. We put all of those pieces together, And what, in about 30 minutes, less than 30 minutes, because we were talking for first 10 minutes anyway. So in about
Yeah.
20 minutes, we're able to build a very simple chat GPT clone. Not a clone, but you send a message and it responds back, getting that thing back from OpenAI.
Yeah.
And this is, any developer can go create an OpenAI key, and this will give them access to that.
Yeah. Correct.
Beautiful. Okay.
All right. So one classic mistake I did, or I let Copilot do here, is there are two ways of calling this setter. One takes in a function. So what we needed to do here is actually use this method where we actually pass in a function that then returns the updated array. The reason we're doing this is that once we go into this function here, the messages array has a value in that closure, and when we update it here with the set messages, when we get back here, it's still the same value. So we essentially need to kind of do this correctly and always make sure that we're updating the latest version of that state. We want to take in or pass in the function where it gets the latest version always, and then we can mutate the latest version of that. So we'll kind of verify that that works. So
Okay.
hello. So now we should retain our actual first message. In the previous iteration, we kind of overrode that.
Gotcha.
And
Yeah.
and like you said, like 30 minutes in, we have a pretty functional thing, but it has one big kind of problem, and it doesn't really show here right now. But if we say like, hey, write me a poem about coding, something like this, where it's actually returning a lot more text. You can see that right now the kind of, this is the built-in indicator for when it's waiting for a response. That took a very long time for it to kind of go through, and it finally did return, but there was a long period of just like, you as a user are unsure, is something happening? Is it slow? Is it broken? What's going on? And that's not necessarily very, very nice. So I thought we could, before we wrap up, take a look at how we could improve this by actually streaming the response. So as the LLM is generating things, it's sending chunks of that response to us over the wire, and we're gonna just return those and kind of update the UI based on those.
Yeah, but because this is not a ChatGPT-like clone, because essentially you ask a question, is processing in the back end and throwing out the answer, as
Yeah.
opposed to, unlike ChatGPT, where it's thinking and spitting out those tokens one by one. So that's what we're trying to do now.
Yeah. So
Okay.
in the LangChain documentation, I'm going to open up the streaming example here just so we can see what the difference is. And there's actually not a whole lot different. So we can see it still has this interface. The difference is that it's returning a token stream instead of just a string. And then there's a little bit of difference in the actual code here. So we're going to go into our backend code here, and I'm going to just copy this. So we're going to have both side by side, just so when you go to the GitHub and you play around with this, you can actually see both of them and how they work. So I'm going to copy this and create a new streaming assistant that returns a token stream, like this. And then what we're going to do is we're essentially going to copy this. So we're going to say streaming assistant. And then what we need to do in order to change a blocking assistant to a streaming assistant is quite simple. So we're going to say streaming chat language model instead of chat language model, and OpenAI streaming chat model. So that's all the changes we need to do. So we changed the return type, and we changed any place it said chat language model to streaming chat language model. And again, everything else works the same. And I'm going to pull that out into a field so that we can create a new function here. And this is what Copilot suggests that we do. This isn't, let me see. Oh, I see what I did.
It's going to be streaming stream now.
Streaming assistant. So I forgot to,
Yeah.
Let's see here. Okay, yeah. Again, we're doing this live, so things are obviously not going to go fully according to plan.
It's as authentic as it can get.
Yeah. So the problem here is that token stream is something just internal to LangChain. That's not something that Spring or anyone else really uses. So what I'm going to do is I'm going to convert this into a more standard data type of a flux. So that's from Project Reactor. That's what Spring uses for a lot of the reactive web stuff. And that's something that we can work with. So I'm going to, instead of having a stream of tokens, have a flux of strings. A flux is a data type that we can subscribe to. So on the client, we can just say, like, we're going to call it, and then we're going to say, like, just notify me as things come in, and I'll handle that. The way we kind of make the plumbing here is we're going to use a sync. Syncs.many, yeah, that's right. If that works, yeah. So a sync is a programmatic way for us to create a flux, and we're going to see if that works. No, that's almost correct.
What we're doing is the standard Spring code here, flux and sinks and all.
Yeah, this is standard Spring code. So this is where we hook these things up. So we're going to call streaming assistant assistant.chat, and then this is not correct. So we're going to say okay. So then we're going to say on the token stream, there's an on next. We're going to pipe that through to the try emit next method on the flux. On complete, we're going to get the completed event, and we're going to try to emit that. And then on error, we're going to say sync.try emit error. So this complete takes in an event, but the sync doesn't have an event, so we kind of disregard that. The last thing we do is we call start, and that's going to actually kind of get the whole process started. So again, a little bit of code here, nothing too crazy. We're essentially just piping from one stream to another, and we have a public method that returns a flux. So I'm going to go ahead and again build the application so that we get that TypeScript generated.
And so the biggest advantage of using this flux is because that is something you can subscribe to, and that gives you the ability to inject it into the browser accordingly. Hey, something has changed, let me refresh it.
Yeah, and really what we're going to do is I created a separate view here. So we have the chat view and we have a streaming chat view here. So we have two different places where we can play. Let's hide that. Let's hide that. Okay, so we have our chat view here, and what I'll do is I'll just copy all of this as a starting point because it's going to be a very similar thing. So we're still going to need a state where we have messages. We still need the same things. We still send messages. It just looks a little bit different. And really, this is the only place where
that is the main place, exactly.
So instead of just expecting one value, what we want to do is we want to subscribe to n values, essentially. So what that looks like is we're going to do the chat service. We're going to now call the streaming chat method, and you can see that appeared here.
Right.
Again, we're going to pass the...
And it's the same thing because it's browser callable, so you can actually, not only is browser callable, so you can call it, but IntelliJ kind of recognizes the API and does that code completion for us.
Yeah. So the difference here is that now we call on next kind of to give it a callback that should be run anytime things happen. Now, the way I want this to work is like if we take a short step back and just think about what's going to happen here is that when we call this initially, we want to again show our first message, and then we start getting words one at a time. So what we want to do is we want to show the response message when we get the first word, and then after we've shown the message, then we want to start appending words to that existing message. So we need to handle the first word differently from the rest of the words.
Right.
If that makes sense. So let's say,
and that's a common thing, right? You're typing a sentence. How do you handle the last comma? How do you handle the first word? These corner conditions are always there.
Yeah, and I'm going to be more specific here that we're getting a chunk at a time. We're not getting a full response. So I'm going to say that if we are getting a response, and if there is actually a response there, sometimes the LLM returns an empty first message, and that kind of makes it look really weird when we just get an empty message there. So we're going to do this. All right, so let's see what Copilot offers us. Set messages. Now because we gave it some context here into what we wanted to do, it actually figured out how to do this. So yeah, it created that, and then it has the username, and it toggles the flag to false. So now we can have an else here. And what it now suggests to do is do the exact same thing, which is not quite what we're wanting to do, because we actually want to append to it. So let's see if we can see if it figures this out. Yes, there we go.
Nice.
So that's pretty nice. Like, this is always a little bit of math, and you need to figure out, well, what's the index and so on and so forth. So this looks like it should work. Let's go ahead and try it. Programming. There we go.
Nice.
Nice. So, I mean, a little bit more complex, not terribly much more complex. These are now, as we're kind of building more and more AI applications, like we at Vaadin, obviously, we're recognizing like, oh, these are patterns that a lot of people are doing. So I wouldn't be surprised that in the coming months, we're going to offer things that make kind of this type of boilerplate less necessary, just methods that say like append to last message or something like that built into the component itself. So you have to do even less. But I think even at this level, pretty readable code, we were able to get quite a lot done in our 40 minutes of coding here, I think. So
think about this. You said in April you were trying to write a chatbot. How many lines of code you would have taken to write something similar to a chat GPT clone at that time, and how many lines it took us now?
well, I mean, this is essentially like 2 implementations here in our 60 lines of code. Back then, I want to say it was around like 400 to 500 lines of code of just like counting tokens and like even just kind of this functionality. I was doing it with, so we can see like if we did a token window chat memory. Let's see what builder dot tokens. Let's say 150. Let's see, new OpenAI tokenizer for GPT. I think this is probably 4. So now with that change, now all of this instead, now it keeps track of 150 tokens worth of message memory. So I was really like, I wanted to get a lot of data in there, but not exceed the token limit. Because what you need to also realize is that the context window needs to not only fit your prompt and your history, but it needs to have enough empty space where the LLM can provide the completion. So you need to make sure there's also enough empty space. And all of that just ended up being a whole lot of math for making sure that that happened the way it needed to happen. And even back then, it was very obvious, like I'm doing the same thing as 1,000 other developers are like swearing about the same problem right now. So it was very kind of obvious that a solution was needed, and it was just cool to see how fast the community responded to that need and started building these tools. So not only do we have LangChain4j, but we see Microsoft building semantic kernel. We have Spring building Spring AI, both libraries that I really want to play with more in the coming kind of weeks and months as they're maturing.
That's pretty awesome. 60 lines to write a chat GPT clone. We have about 10 more minutes. Walk us through some other fun things that LangChain4j can do.
So some other fun things, I think. So if we go back in here, I think some of the cool things is doing like structured inputs and outputs where you
Make that
can.
screen bigger, please.
I'm sorry.
Yeah, make that window bigger for the. Yeah, there you go. Perfect. Thank you, sir. That's beautiful.
So here, for instance, you can define, again, interfaces where you can define how it should map from an LLM output into a specific type of message. So that way you can extract certain data types or even objects out of the, like Java objects out of the response. So that's pretty cool. the other, let's see here, where are we? And really, like, this is a gold mine if you want to understand how all of this works. But this one especially is kind of interesting as you get to the next step, where typically if you're building a business application and you're integrating AI, you want it to not be a generic AI, but you want it to understand something about your business context. And this here explaining how you can load different types of documents and make those available for the LLM as it's answering is really helpful. So that way you can have a ChatGPT type of experience, but that is aware of all the kind of business peculiarities of what you're building.
And
So
this is where
that
you build. So this is the functionality that you could use potentially to build your RAG pipeline.
yeah, this is exactly. So typically this would be split into two. So you'd probably do the document loading and kind of embedding generation more on a build server that maybe whenever your documentation updates, it just regenerates embeddings for that specific change document. And then you would then connect to that same database from your running application and use that as your data source. But this is pretty straightforward. You can just give it essentially a folder where you have all your stuff, and it knows how to parse most documents. It has pretty good kind of sane defaults for how it splits those into smaller chunks and creates vector embeddings for each of those and makes them accessible to you.
So just loading these documents into ChatGPT is enough for you to create the vector embeddings. And then when you are querying your version, it is going to leverage that context automatically.
Yeah. Let's see. I'm going to open up another project here just so I can maybe show some code here, and
Yeah.
let's see if we can make this happen. So I'm gonna shut that down so we don't have two different apps running on the same port. So this is another talk that I've been doing, and this is very much inspired by the talk at Devox that you showed, where I just essentially added a UI on top of that so we can more visually see how we can interact with a LLM and actually perform business tasks. So it's taking a little while because I apparently updated the version back then. But all right, so this is the hypothetical situation here is that we have a car rental agency, and this here on the right side is a live view of our database, so we can see what bookings are there. And this is kind of the customer-facing chatbot here. So what I've done, let's close annotations. So what I've done here is I have loaded a terms of service document, and I've ingested that into a vector database. And then here, like, this is a little bit more code.
What vector database are you using for that?
What's that?
What vector database are you using for that?
So for this one, I'm using a in-memory embedding store. So this is running all in the JVM that could be plugged into any other. Again, I'm using an embedding model, which is also all in JVM. So this is easy for you to clone and just play around with the same one.
And that embedding model is a LangChain4j API?
Yeah.
Got it. Okay.
So really, so again, like so without going into all of without going into all of the details, we can see that this is the exact same code we had in our example, but just with a couple more things. So we're still streaming chat language model, but I've added this retriever here, which uses that vector embedding. I've also added a tools, which is a Spring Bean that makes these two methods available as methods that the LLM can call. So that makes it possible for me to be like, hi, my name is Robert Taylor. My booking number is 105. Can you please cancel my booking? So let's see if this works. Hello. All right, so it's pulled up my details. It's saying it's from December 16th to 20th. It's in luck. It's within our booking cancellation. I say thanks here, and hopefully that will go ahead and cancel my booking, and that's gonna show up here as canceled now in our database. So this is like taking that example that we just did, but adding a couple more tools. So I can share this link as well with the audience so they can kind of see the
Yeah,
simple
please do.
and then
Please do.
the next one. But it's really powerful once you have that basic kind of pipeline there. You can add more things to it. You can plug in more
That's beautiful.
tools and things.
And this is the first live demonstration of a RAG pipeline that I've seen, that how terms of service has been embedded, how you are given access to the database, and based upon that, the model is able to interpret the information and make a call. Can I cancel the reservation or not? Now,
Yeah.
so
Yeah.
automating like a lot of those tasks is super important.
Yeah. So
Beautiful.
if we tried here, sorry. Hi, my name is John Doe. My booking number is 101. Can you please cancel my booking? All right, so let's see here. All right, so now we can see that this is
Right.
not
Right.
not something that was allowed to do, so it just denied me. So we can it's very like the usefulness and power of these tools just increases exponentially as we make them aware of our specific business domain rules. We give
Massive.
it access to a limited set of tools for actually pulling live data and working with that. So that just makes it so much more powerful. But you can see like how quickly we're able to get started, and then like the relatively small amount of changes we needed to do to that to then just plug in these more advanced functionalities.
Marvelous, actually. No, Marcus, I'm going to hide the screen away. It's a beautiful demo.
Yes.
But let me summarize here. So, what we did today is we use Spring Boot as the backend, we use LangChain as the LLM wrapper API, and specifically we use LangChain4j, which is the Java binding of the LangChain LLM wrapper. We use that to connect to the OpenAI LLM that is accessible to everybody. With that, we built a simple chat message version, back and forth, no context. Then second we built is a streaming chat version, which is very much like a chat GPT clone, where as this thinking is spitting that thought out and you can do it. And then towards the end, we looked at sort of how you can incorporate your business context into the application and sort of making that quick, retrieval augmented generation RAG pipeline for your application. All of this done using LangChain4j.
Correct.
My God, that is beautiful. In 1 hour, how productive we were. I can't even imagine what nightmarish experience it would have been several months ago, and how much boilerplate, wrapper, API, this, that code would have to be written. And what I'm equally excited about is the opportunity that we have in front of us for the next several months on how much of this code is going to get improved.
Yeah, exactly.
Beautiful. Marcus, any last parting remarks, words?
Well, first of all, thanks for having me on your webinar. It's always a pleasure. I will share the GitHub links to everything that we saw here. So if any of this seemed interesting at all, you can just check them out and play around with them on your own computer. The only thing you need is, again, that OpenAI API key. It expects it to be in that environment variable. So you can either put that like system-wide on your computer or just define it for your specific project in your ID, and you should be good to go.
And when I tried that code, that is the exact problem that I was facing. So I know I bumped into that. So that is a genuine problem. Where can people find out more about Hilla?
Hilla.dev. So HILLA.dev is the place to find
And the
any
very last
anything.
question, what does the name Hilla signify?
Hilla is a cloudberry, so it's like a sort of a raspberry type of berry that grows up in the like far north of Finland. We're a Finnish company, and we're pulling inspiration for a lot of our product names from Finnish nature. So Vaden itself means a reindeer, and Hilla is a berry, and it kind of lends itself to a really fun logo as well. So we liked it.
Wonderful. And as I said in the beginning of the episode, I finished all of my blueberries as well. It was such a fun episode. too early for popcorn, but really enjoyed my blueberries and the wonderful episode here. Thank you, Marcus.
All right. Thank you, Arun.
All right, we're going to end the stream now. Bye-bye.
Bye.